So in a previous video, we talked about the definition of linear equations, and in this video, we're going to explain why they are defined in such a way. The definition of linear equations can be understood in a geometric way. For example, in the x-y plane, if I give you three curves, the curves of function f, curves of function g, and the curve of function h, and tell you one of them is linear and the other two are not, then which one are you going to choose? You're probably going to choose the curve of y equal to f of x because that curve is a straight line. And if I tell you one of these three surfaces can be represented by a linear equation, the other two cannot, then which one are you going to choose? You're probably going to choose the one in picture A because this is a surface that is flat. So let's look at the two pictures you would associate with the word linear and see what they have in common. First of all, what equation would you use to describe a straight line like this? So you probably learned different formula for writing down the equation of a line. For example, the slope-intersect form y is equal to m times x plus b. This formula works for most of the lines, but in the case where the line is vertical, then you need the equation x equal to a constant, for example, x equal to a, to describe this kind of a line. So a universal formula to write down the equation of a line is really a constant times x plus a constant times y is equal to a third constant. Looks familiar? This is a linear equation about the variables x and y. Similarly, you probably learned different formula to write down the equation of a plane, but a universal equation for any plane is a coefficient a sub 1 times x plus a coefficient a sub 2 times the variable y plus a coefficient a sub 3 times the variable z is equal to another coefficient d. And this equation, as we recognize, is a linear equation about the variables x, y, and z. So if you compare the equation of a line and the equation of a plane, you notice they have something in common. The power of those variables x, y, z are all 1, and there are no terms like x times y, x times z, x times y times z, etc. And there are also no other functions like sine of x, exponential of x, etc. And you can generalize this form of equations to an equation about n variables. Which is the generic form of a linear equation about n variables.